Let's work this Indian School Leaving Certificate Examination question that involves quadratic equation and a lot more in the deciding on the domains of a given quadratic equation. An important thing of solving a quadratic equation problem is not just to find the roots or the answers. Instead, it is important to know which of the answers are valid to be a solution for the given equation. Here we are given an option to solve one of these questions, but we can do both at this moment. The first one is saying the sum of reciprocals of Cavalli age, that is 3 years ago and 5 years from now, is 1/3. Now the question is to find the present age. This is the first question. The second one is also the one involving a quadratic equation and looking into the valid answers or domains of that equation is it possible to design a rectangular park of perimeter 120 meters and an area of 900 meters square? This is just asking if it is possible or not. If that is possible, we need to find the length and breadth of this park. Let's do the first question. The current Cavalli age is, let's say, K. Now once we have assumed the current Cavalli's age here as K, then Cavalli's age 3 years ago is going to be 3 minus K minus 3. That is just 3 years before. The reciprocal of K minus 3 is in fact 1 over K minus 3. Okay, we have this one. The other one is the Cavalli's age after 5 years is going to be K plus 5, which is here. The reciprocal of K plus 5 is 1 over K plus 5. Now we have two equations. The sum of these two reciprocals is 1/3. So we just put the equation as 1 over K minus 3 plus 1 over K plus 5 is equal to 1/3. This is what we solve. Now we take as the denominator something like the LCM of these two factors, which is just the product of the two factors themselves. So K minus 3, K plus 3 as the denominator. When we divide the denominator to K minus 3, we're going to have a K plus 3 here, and then we have a K minus 3 here. Good. Is equal to 1/3. Now we have this one. So the denominator is K plus 5 and K minus 3 all together. So K plus 5 plus K minus 3 is 2K plus 2. On the denominator, we need to factorize and see. We need to multiply one another and see what we have. So K into K plus 5 minus 3 into K plus 5 is going to give us K squared plus 2K minus 50, which is 1/3. Okay, now we have this one. Let's continue. So we need to do a cross product on this one. Then we're going to get as 3 times 2K plus 2 is equal to 1 times K plus 2K minus 15. Okay, 6K plus 6 is equal to K squared plus 2K minus 15. We just put all together in one side. I have chosen to keep this one as it is. Okay. And I will move this one to the other side, in which they have to change their signs up here. When we simplify this, now we get this quadratic equation, which is K squared minus 4K minus 21 is equal to 0. Now we need to first check the discriminant of a given general quadratic equation formula. Maybe, as we remember, the roots of any given quadratic equation in which its general form as ax squared plus bx plus c is minus b plus or minus square root of b squared minus 4ac or divided by 2a. This is the one. To avoid just complication or rewriting this thing again and again, just it's better to do the discriminant first. That gives more clarity on the equation or on the page here. So b squared minus 4ac is what we are going to decide. This one here. B squared minus 4ac is equal to minus 4 the whole square b squared minus 4ac, which is 16 plus 84, which is 100. Lucky it is a perfect square. It's 10 square. So we keep in mind that, no problem. Now we have b squared minus 4ac. So we can put the general equation of the quadratic equation that k is equal to minus b plus or minus square root of b squared minus 4ac over 2a, in which minus b is going to be 4. That is because b is minus 4. So 4 plus 4 minus square root of 100 divided by 2 is 4 plus or minus root 100 is just 10. So 4 plus or minus 10 divided by 2. Now we have two solutions here. One is 7, another one is minus 3. It is where it is very important to decide on the domain of a given quadratic equation in real life problems before we just solve. We are looking into the age of a person. If that is the case, the age of a person is just a counting number or a natural number in which it should start from 1, 2, 3, 4, whatever, how long a person might live. So if that is the case, we have to take only the one of the two ages, which is 7. 7 is a natural number or a counting number. There is no negative age. So the domain of this equation is natural numbers. Then what is in the domain is 7. So it is what we have to choose. So the current age of Kawali is 7. This is how we solve it. And we can verify this answer by putting into the original equation, in which 7 3 years ago is going to be 7 minus 3, which is 4. Again, 7 after 5 years is going to be 7 plus 5, which is 12. So the ratio of 4 into 12 is 1/3. So the answer was great. The second part, which we have to choose in one of the questions to solve in the exam, there is an or. We do either the upper one here, or we do the lower one here, one of the two. Let's see now the second one, how it looks like. The second one is saying, is it possible to create a park of a perimeter 120 meters, and the area of the park is rectangular. Actually it says rectangular park. Keep in mind, rectangular. It doesn't matter really. On the answer which we get, we will see that one mathematically. So the perimeter is 120 and the area is 900. So from the area, which is length times width is equal to 900, we have one equation. From the perimeter, length plus breadth plus length plus breadth, which is going to be 2 lengths plus 2 breadth is 120. This is the second equation. If that is the case, we can simply divide both sides by 2 here, and we can have a simplified form of that same equation, which is length plus breadth is 60. From number 1 here, length times breadth is 900. So we can say breadth is 900 divided by length. This is what we are going to substitute into equation number 2 and see what we get. Once we substitute that into equation number 2, we get another quadratic equation in here. 900 plus length square is equal to 60 length. When we collect terms in one side, we have another quadratic equation in which we have to solve for the value of length. Again, we go back to the discriminant of this quadratic equation and see what we have. We have real roots, imaginary roots, and or one root whatsoever. That gives us the character of the quadratic equation. If you want to know more about this one, I have a lecture on this same channel. You can find it up and you can go through it. It's in detail there. So here, b squared minus 4ac is minus 60 square minus 4ac. We have now a b squared minus 4ac is equal to 0, means with discriminant 0, that gives us that it has only one root or two identical roots, you can say. So we have only one root now, we know. Okay, things are gonna be now much simpler. So the length is minus b plus or minus b squared minus 4ac over 2a is the general formula for a quadratic equation solution. From that, we have here minus b as 60 plus or minus root 0 over 2, it is 30. Now we have length to be 30. But we know one thing, that the perimeter is 120, means length plus breadth is equal to 120. It is there in equation number, I think 2. It doesn't matter anyway. So 2 lengths plus 2 breadth is 120. Length plus breadth is 60. We already have it. So the breadth is 30. That is 60 minus 30, because we have a length of 30, which we found it from the equation of the quadratic equation up here. Okay? This is what we have. Now we have we have only one solution for this one, and it's good enough that we are looking into a distance, and of course the values which we got are positive. If we get a negative value in case, that's not going to be valid, because distance is also not measured in terms of negative numbers. It's just like the absolute or the modulus of any number, which is a positive part of it only. But it's good enough here that we have a positive number. Now we have 30 here, and the question is saying, we need to see here, is it possible to design a rectangular park? Again, this term, we can speak this term in terms of mathematics. It is a bit different from when we talk about it in terms of an ordinary life out there. We got a square here, 30 by 30, in which when we verify 30 times 30 is 900, and the perimeter is also 120. So can we say that yes, we can be able to do the rectangular park? The answer is going to be yes. That's because we're talking about mathematics. In terms of mathematics, any square is a rectangle. It is true. If a quadrilateral is a square, then it's a rectangle. That is true. But if a quadrilateral is a rectangle, it might not be a square by definition. Something to be a square needs to have all sides congruent, equal, and then it should be 90 degrees. Something to be a rectangle, it needs to have 90 degrees, that is true, and opposite sides are congruent or equal. Then, if a rectangle is by definition, say, the opposite sides has to be congruent. It's not talking about all the sides. Does a square fulfill that definition? Is the opposite sides of a square are congruent? Yes, it is. That means if something is a square, it fulfills the definition of a rectangle. The opposite sides are congruent does not mean all the sides are congruent. The other way around, it doesn't work. If the question was saying, like, are we be able to design a square, and if we get a rectangle, we should say no, because a rectangle is not a square, not necessarily a square. In other words, if something is said to be A is B, means in all cases A is B. In all cases. It might be true in some cases, but to make it a true or a false statement, it should fulfill all the cases. So some rectangles might be square, but not all rectangles are going to be square. The other way around, it is true that all square are rectangles. So whatever we get here, square shape, divide circle, the answer should be mathematically yes, it is. We can make a rectangular park. Why? Because a square is a rectangle. But when you do an ordinary do within the society, you need to verify this one. You need to talk to your customer to make sure all things are clear. But the mathematics term does not need any clarification here. Square is a rectangle, and yes, we can be able to design a rectangular park of 30 by 30. Thank you so much for watching the video.